Yes, so we are live now and we are starting. So, as usual, welcome everyone, and this is great to see you again after the first event that Mahesh did in in the last month, and this is the part of the series, and this is covered with Alibaba Cloud certificate and a Clouder badge, which will be provided directly by Alibaba Cloud after the exam when the last session happens. So this is the whole master class is on Terraform, and you can't get better than it. I'm 100% sure in the industry. Mahesh is the master, and he has been working in the industry and in the solution architecture, system design world for long. So as I said, this is with free Alibaba Cloud certification. Day one was Terraform behind the scene hands-on course, and Mahesh quite nicely demoed us on providers also, and how you can create your own provider. There are multiple session in the past done by different speaker on different topic on defining creating your own provider or something similar to it, but this is in fact is a master class. In fact, Terraform itself is a concept based on a provider based approach where you can directly script up your whole cloud formation and even your the um, next gen container and Kubernetes with stack. But obviously having your own provider is something which will give you a neat and clean and a very nice view on perspective on designing systems, uh, and Terraform is a good example for it. So and you can go and access the course which is live on our platform. You can simply search for either by the course name, or you can simply search for Terraform and you'll get that. The next session today is Terraform for Cloud, where Mahesh will give you the perspective of using Terraform exclusively for the cloud platform. At the end also there will be a session on using Terraform with Alibaba Cloud when the certification will happen. But certification will cover the whole perspective of Terraform, the complete questions from the complete master class, and you can go it. Believe me, you can go it anytime on our platform, watch the recording, take a perspective around it, and then give the exam. And that's completely free. Terraform Cloud, and then the third one will be Terraform Best Practices and Users Enterprise Environment. That will be on 27th of November, and we have given a time for you so that you can also go through internet, have questions. If you have anything specific, you can go through it, and you have, I believe when you come in the third session, you have a lot of knowledge around it, so that when Mahesh captures around the best practices, you can easily understand and take it right away. So the hosting team as usual, right? So we are supported by under guidance from Sweta Singh, who is the co-founder. Dheera Singh is our voluntary evangelist, and he is from US. And then I am founder Anjani Kumar. I have with me Gavaskar, who is the delivery director, and he heads the whole fifth IR training and evangelism platform. And then we have around 10,000 plus of top industry mentor and support who support right across the globe. You can go on the website and find many of the courses or session given by different experts, and they're very short courses. It will give you a great glimpse around what is happening around the industry. And then supported a fifth IR team in US, India, and Singapore, and as I said, volunteered by Mrityunjay and multiple people. Fifth, as you know, is almost covering all part of the globe now, almost 80 country from where the people join. Uh, Community benefits, so you get London certificate and exams. You get partner certificate as you are getting here for the Alibaba from the Alibaba Cloud. Similarly, for other cloud platform we have, and we keep on announcing those sessions. Then something happened, so I'm just trying to share my screen again. Just give me a moment. Bear with me. And then you have say hub for educator, learner, seekers, and all. You can apply your CV and do a lot of things with this platform, and you also get community evangelist certificate and a lot of goodies. So how we can claim your certificates? You can simply go on that website, search for Terraform, search for session 2, and then once you are there, you will be able to chat with our on our platform, and also there is a certificate link through which you can claim your certificate. These are all the fourth generation of transformer who has joined us as a guest in the past. Mahesh, right? So Mahesh is just give me a moment. So Mahesh has started his career as like from a developer, raw developer, and and he is a CTO now with a firm. He has worked at a very premium role as a director engineering in Publicis Sapient. And he has led the big team in Publicis Sapient from UK. And many of the past colleague or anyone who knows him know him as a technologist, and he's not just a leader, he's a technologist, and he has proven himself with the time. And it's like uh, growing himself up from a developer to that level is just an example. Who is sitting up and going to give you the session today, and you will be like love, always people when like people are a lot of people are fan of him. He's a Microsoft certified. He has also Azure Security Engineering Associate certificate, and he has also given a very nice session on Zero Trust, which is a very important topic nowadays. And you can go and search on Zero Trust on Fifth IR and you'll see the session. You can connect with Mahesh, and he does a lot of writings on Medium also. You can get everything about him on LinkedIn.com in Inspired by Tech. It's very easy. Inspired by Tech. You just have to type, and you can easily connect with him. This session, as always, has a participant certificate because the exam is set up for the last event. So you can get the participant certificate. Speaker code will be announced, and the final certificate will be like this, right? There will be Alibaba Cloud Academy certificate, and you also get a badge directly from Alibaba Cloud. And over to Mahesh. And there is a separate few quiz also, and you will get the goodies. We'll come to that. Mahesh, please.
Cool. Let me start sharing. Can you see my screen?
Yes.
Okay, perfect. All right. So there's some problem with my video, looks like. I'm not sure, but anyway, I'll just stick to the presentation for now. Obviously, as always, we'll have some demos, so I'll switch between. Let me start sharing between. See my screen. Actually, there's a lot of echo. Okay, perfect. All right. Maybe is Anjali to reduce the maybe my video looks like. I'm not sure, but anyway, I'll just stick to the presentation for now. Obviously, as always, we'll have some demos, so I'll switch between start sharing between see my screen. Okay, I just reduced my volume for now. All right. So for people who didn't attend the last session, obviously I'm a chief engineer at DLT and working on building some financial services products within wealth management. I have a lot of experience in AWS and Azure, and today's focus is continuation of the last session that we had. So the last time we covered a lot about providers. I'll do a quick recap of that, and then we will move on to AWS and Azure resources and how we can use the native providers to build resources on the cloud providers. I'll also talk about manipulating state, just a bit more information compared to what we saw last time. And then we'll also look at modules and importing resources. The last session, in a nutshell, there were two areas we covered. So just an intro for Terraform for people who hadn't used it before. So I covered the terminology, the sample Terraform that I showed with Docker. We covered the main stages of init, plan, apply, and also how to destroy infrastructure. We talked about a Terraform state a lot and deep dive into how to use it and manipulate it if needed. We'll extend that further in the cloud with the cloud resources today. And then the other thing I showed you was also how to build your provider with the simple API that I had created. There's some helpful links for anyone who's interested. So just again, high level, the stages we talked about when using Terraform were init, plan, and apply. And if you want to destroy infrastructure, you can invoke destroy. Again, we will go through this in the demo today as well. When it comes to providers, there were three big components or pieces. There was the target API. Last time I had this goal management API, which I built using Golang. And then there's the Terraform core, which does the base core sort of engine, which basically looks at your Terraform code and generates like a graph of dependencies and resources. But the actual work is done by the plugins or the providers, which is what we built last time. We built a school management provider using my API to create, update, delete schools. So you can go back and check that previous session if you want more details. With respect to today's session, there's a few prerequisites. Because it's AWS and Azure, I will focus on both of them, but you need to install a few tools. I will talk through how to use them basically, but I think these are fairly available. When you see the PowerPoint presentation later on, you should be able to follow those links and install. But on AWS, I use the AWS CLI and AWS Vault, which allows me to then log into multiple accounts and run Terraform. So you should install AWS Vault before following the samples in this session. And then for Azure, it'll be just Azure CLI and Terraform basically, which I'll be using on my machine. You'll see how to use them as I go through them. So to begin with, when it comes to AWS, just like the previous samples that I showed in the last session, you obviously have to define the provider, and then you have to provide the specific credentials for the provider that you are going to use. Now, in this case, AWS provider, there are many different ways in which you can provide credentials. I won't go through all the details of that, but I will use AWS Vault, and I'll show you how those sort of credentials can be passed at runtime using that. There are other ways in which you can do that, and many secure ways of doing it, but it's a topic for us for the separate explanation. And then you just reference various resources. So in my case, I'm just building a simple virtual machine on my AWS account just to keep it very simple so we can go through it very quickly. So the first step is here, it references and grabs all the machine images. So like an image that Amazon, the operating system that I want to use, in this case, it's Amazon Linux. It just search for those, and basically based on that image, it will create a host on AWS. So it's a very simple code that does that. Now, if I switch back to my IDE, just like last time, I've got the provider here, as I said, and then in my main TF, I've got all my resources. So I've got the data source lookup for the AMI to query and find out all the Amazon AMIs that exist. And then I got a couple of security groups resources. And then the real resource, which I'm trying to provision here, is a virtual machine. I've used this because I think most people understand virtual machines. I think we have a mix of audience. So hopefully this keeps it simple and people can understand how it works. But this is how I'm just referencing the data source, which is the operating system for the Amazon AMI, and then providing any various resources. And the SSM, I've kept it blank for now. This is basically if you want to set up SSM sessions to be able to log in to the virtual machine. I won't go deep into that for now. And then I have defined some variables. We will dive into variables separately in the next session, but just an idea of how, instead of hard coding everything into your module, how you can reference variables basically. To run this, as I said earlier, I am going to use AWS Wall. So one of the main things for when it comes to AWS is setting up your AWS config. So in my config, I have this profile, which I've created, and it points to my AWS account basically. This is the most, like the basic step you need to perform when you are working with multiple accounts. If you're working with multiple accounts, you can create multiple profiles in this particular file, so the AWS config. And once you add them, your AWS Vault command will automatically detect them. But before you can use it, what you need to first do is log in. So, add that account specifically into AWS Vault. What AWS Vault does is, rather than embedding the credentials into your file, it will store it securely in your keychain or operating system using the native encryption method. So in this case, what I'm going to do is I'm going to use AWS Vault to add this particular profile, which is what I am going to use to execute Terraform. So if I do this, it will ask me for an access key ID and secret, which you can easily generate from your IAM. So if you've logged into AWS before, you must be familiar with the security credentials. You can generate access key ID and then hello, I'm Mahesh Patel, and then you can use that to log in. So in my case, obviously, I have already generated, so I'm just gonna enter my access key ID and the access key itself. Just give me a moment there, and then that's it. So once I do this, I have entered it, and it will ask me for my keychain password. And there you go. That's it. It's already now configured to use that access credentials for that particular profile. So now if I do AWS login IDT default, which is my profile, it will prompt me for the password of my keychain. And then obviously I will be in. So it has logged me into my AWS account automatically. Basically just stores those credentials in the keychain with a Mac, because it's a MacBook. If you're using some other software, if you're on Windows, it would have used, it will use, I don't know, but it stores somewhere in the user secure store. Now, in my AWS account, I have some S3 buckets, which I will go through later on. But if you look at the virtual machines, I do not have any virtual machines, at least in the London region. So this is what I'm going to do now, is to run my Terraform and basically set up the virtual machine. So I'm in this folder. If I look at this, I've got my Terraform code. Now, if I run Terraform init, and just like previously, I should be able to initialize it. It should be fine. But if I run Terraform plan, it will complain that it cannot find the AWS credentials. So what I need to do is I need to use, as I said, it's not able to get my credentials. So what I would do is I will use AWS Wall exec. I provide the profile name, which is I had just logged into, which is a IBT default. And then this is the syntax for running any command. So I could do Terraform run. It will prompt me again for the password. And once I log in, it will be able to access my AWS credentials, which it sets into the environment and basically run the Terraform plan. So there you go. So it's done. So it's showing me the resources it's trying to create. We'll just quickly talk through this plan. So as you can see, there's the AWS instance it's trying to create, which is the virtual machine. And then you've got security groups, the two security groups that I was trying to create. So it's all, in all three resources. So let's go ahead and apply and so approve in this case. So it doesn't prompt me for, so there you go. It's going to take a bit of time while it runs, just a few seconds, I think, because it's a virtual machine. And once it's set up, we will go back to the AWS account, and I'll just quickly show you what it's done. So there you go, it's done. So the creation of the resource is complete. So if I go back to my console, there you go, it's created the virtual machine. Secondly, if you want to see the Terraform state, in this case, I'm managing the state locally. So the state's right here. You can see that it's already added the Terraform resource. So the Amazon Linux v2 version, in the image, the data source lookup is here, as well as the AWS instance, along with all the properties that it created, basically. So they've all been set up here in the Terraform state file. So let's quickly just, as always, destroy it. So we can go to the next step. And it will do the same thing. It will just go ahead and delete all the resources that it just created. This might take a couple of seconds. So while that's happening, let me just quickly go through the next section where now you've seen the state file. As obviously, when you are working in large enterprises and companies, you do not want to maintain the state file locally like this. So what is better is to maintain this, and I'd mentioned this previously, is to maintain it on the cloud. So if you're on AWS, the easiest storage that you can use is the S3 storage that comes with it. If you're on Azure, it would be stored on the AWS Azure storage accounts, blob storage, basically. So if you want to do that, it is as simple as just adding to your Terraform this backend S3. So in case of S3, it would be an S3 backend. If it's Azure RM, it's got a different backend. You can find more details on this link here. But that's all you add, and then automatically what it would do is, instead of keeping the state locally, it will upload it to the S3 bucket or the storage account or any other backend that you use. There are many other backends you can use. The alternative way is just to add this backend and pass the actual configuration as part of the command line. So when you do Terraform init, if you pass the bucket name, key, region, it has the same effect as passing them as part of these parameters. So there's two different ways to do this, and more because in your dynamic environment, when you're doing this through the CI/CD, it's much more handy to use these command line options. So I'll just quickly run that code as well and show you. But before that, as you can see, these resources have been that I just have been destroyed now. So if I go back here, it must be terminating. So this instance is now terminated. So what I'll do now is I have the same code with a backend state. So I'll just talk you through that. So this is the backend configuration that I've got. So I've got this bucket, S3 bucket called Best Practices Terraform State, which I've created for this particular Terraform. I've mentioned a key here, and the region is again London, US2. And the rest of the code is exactly a copy of the previous code that I had, right? So there's the main TF with the providers and the variables. There's no difference at all. So basically, I'm just creating the same instance, but with the backend S3 state. So before I execute this code, if I show you my backend, so if I go back to S3, S3 buckets, and if I open this particular Terraform, S3 bucket, you can see right now it's empty. It has no data in it. What I'm going to do now is switch to that directly. So slash to yeah. So again, if I run, I have to again use the same AWS Wall to run this code, because obviously that's how I'm managing my AWS credentials. So I will run Terraform init in this particular directory. And as part of the Terraform init, it will obviously initialize my plugins and Terraform State, as I had mentioned previously. So it creates the HCL file and the provider plugin directory. If I do plan next, you will see that it will again show a very similar plan to the last time. There will be no difference really, because the resources are the same. So it says 3 to add, and everything else is exactly the same. There's no real difference. But when I do apply, instead of creating the state locally, it will provision, create the create the S3, maybe I didn't know, sorry. It will create the file in the S3 bucket. Sorry, it looks like I just canceled it by mistake. So let's give it a second there. Yeah, so as you can see, it's running the Terraform, and then if I come back to my bucket, soon enough, once it's done executing this Terraform code, it would have created the Terraform state on the S3 bucket. So here you go. So this is the path I provided, Terraform best practices, and the file name is this that I'd given it. So if I download this again, you will see almost exactly the same state as the last sample. So it's exactly the same. It's got the data source, it's got the security groups, and it also has the virtual machine. So it's exactly the same file, except that instead of maintaining it locally, it maintains it on the cloud. So this is the path I provided. Again, if I do a Terraform destroy, it will delete it as well. It'll be again the same principle as the last time. No real difference, except that the state is still managed. And you also will see that it hasn't really kept any local files. So there is no Terraform state here locally. Now this is just inside the .terraform folder, which is not really used, so it just initializes a file. But really, just like in this folder, you had the Terraform state locally. It isn't created here; it's just maintained on the cloud. So if I delete that, so right now you can see I got this file is 9.8 kilobytes, which is basically the whole state. After destruction, it will update the file, and you'll see that the file size will also drop, because it would have no resources. It will just have a blank array, which I will show as soon as this is complete. Give it another second.
next-gen container and Kubernetes with
So
stack.
let's go.
But
Okay.
obviously, having
While that's happening, we can actually check. So this was the second instance it had created. This was the first one. It created the second instance in this second run, and it's still trying to shut down or destroy the particular virtual machine. So while that's happening, maybe we'll just proceed because it might take a bit of time. And once that's done, obviously, as I said, the file size of this particular file will also drop because it would have no data in it. So in parallel, I'll talk about another concept related to state. So it's all perfect when you're managing state on the cloud, and obviously you should do that. You should always use an S3 bucket or depending on the cloud provider, the native sort of implementation of the backends. Although the problem you still will have is when you have multiple users running your Terraform code. So in this case, for example, I have 2 users who are trying to run Terraform, plan, apply, whatever. If they're using the same backend, which is what will be the case, they should be using the same S3 backend or Terraform State file. You may have challenges, race conditions, and state might get corrupted because once trying to apply and at the same time someone is trying to do a plan, when they try to apply that, the situation changes, the number of resources change. So what you want to typically do is in Terraform is there's a concept of locks. So you can actually apply locks on top of the Terraform state. Now, based on the provider, so in case of AWS, they recommend using DynamoDB for the locking of the Terraform state. So you create a DynamoDB table, and then you just specify this particular line item here, and then automatically it will start using that table to maintain the state, whether it's locked or whether it's someone using. So what happens is when a user starts to execute Terraform code, it will first lock the file before it starts to make any changes. And when it's locked, no one else will be allowed to access it. With Azure, it is handled natively because storage accounts have built-in locking of files, which is why you don't really need to do anything special. But with AWS, you need to specify this additional configuration. But that's the only change. So when you are doing this in an enterprise in your real-life experiences, I would highly recommend not just maintaining the state on a backend like S3 or object storage, but also adding this locking using DynamoDB or the native provider, because otherwise you will run into consistency issues over time. So with that, if I go back, this is now destroyed. So if you go back, my resources have been terminated. They will go away shortly. And if I refresh this, you will see that this file size has now dropped. So if I go back, if I download this file and that it has no resources, which is because I deleted those resources. So that's basically how, in a nutshell, how states work. And backends such as S3 can be used to store the state in a central location. The only other thing I would like to now cover is, with respect to states, is how to manage or import resources. So for example, let's say in my case, for example, I've got this code where I've created an S3 bucket already. So if you remember from the last run, I had this bucket IBT best practices, which is this Terraform state file. I just showed you the list of buckets here, right? So this is the bucket I've already created. Now, if that bucket is not maintained using Terraform, so if it's not in my code, what do I do? How do I basically ensure that I can manage it using Terraform? So I have this piece of code which has basically 2 resources. So it's got 2 S3 buckets. One of them is commented for now. And if I run this code now, what it's going to try and do is, because my Terraform state does not have any resources, it's going to go ahead and try creating the resource for me. So let me just show you quickly how that would be. So again, same concept. If I do Terraform init and then Terraform plan. So the plan would show that it's trying to add a resource. And if I go back to the plan, as you can see, it's trying to add the same bucket which I've already created. Now, what will happen is when I run apply, it is going to fail because the bucket already exists. So instead, what we should do in this case is import an existing resource into the Terraform state. And the way you do that is there's a command called Terraform import. So with this, for example, you provide the path to the actual resource. So in this case, it is AWS S3 bucket.tf state. This is the path of the resource, which is basically, in general, it's just the resource type and the name of the resource you specified. So it's that. So you specify that, and then you specify the name of the actual bucket, which is, having best practices. So if I run this command now, it will try and import the status, and it says import was successful. So if I go back, you will see now that the Terraform state, TF state has updated, and it has imported this AWS S3 bucket.tf state resource with the appropriate details of the particular bucket as it exists. Now, if I run, the one other thing I can show you is if I now run plan against this code, Terraform, you will see that it will recognize the resource exists. So instead of add, now it's saying that there is no resources to add, but it has recognized that there is a change to the properties of the resource. So because this resource was already created, I think the ACL, these two properties from Terraform, which is basically to set this as a private ACL. Although it's a private bucket, there is this property which just lets you set ACLs that has not been configured, and the force destroy option is also not configured. So it's recognizing those two changes exist, and I can apply them. So it will automatically now apply those two changes on an existing resource versus previously it was showing that it was trying to add a new resource. So this is how you can basically, in large infrastructure, when you have already created your resources, and if you want to import them into your code, you can write your resources and import your code accordingly. That way, your resources don't have to be created based on the code. Now, there's another way to do this, which is a really dirty and ugly way of doing it. But if you have to, you can do it essentially, and that's by using an existing state. Sometimes you may you may land up into issues where your Terraform state gets into a weird state, and you need to sort of fix names and IDs and stuff like that in Terraform code. So if you have that issue, what you can actually do is also, in my case, for example, I've got two S3 buckets in here, right? I had commented the previous one. So let me now uncomment this and show you the other option. So if in this case, now I run Terraform plan, they recognize that there is a new resource that I'm trying to add. So want to add, which is this S3 bucket. But if you look at my AWS console, that resource already exists. So I have already created this bucket previously as well. So both of these existed. Now, instead of using Terraform import, in this case, what I'm going to try and do is I'll show you how to do this from the state file itself. Again, not recommended unless you really have issues and you know what you're doing. You can use this course of action. But in general, what you do is you copy that under, I'm sorry. So if I go back to the this particular Terraform state file, which is this, as you can see, this is the resource. So it was the Terraform state resource. So all I do is I'll just copy that resource. I will add a comma here because it's an array. Paste the same details back, and I will replace the names of all the name of the bucket from all of these from this particular resource, basically. So I would replace that with the best practices one. So there's only 3 or 4 places. So they're all replaced now. If you go back, I've got 2 resources now in here. So I've got the main Terraform state resource, and I've got the second one, which is the one that I just added. So if I now run plan against this, I manually added this to the Terraform state. If I do run Terraform plan, sorry, it would. Sorry, I made a small mistake there. I forgot to add one more change, which was, so if you see this list of first 3 attributes, the name of the attribute should match the name of the resource. So in this case, it's AWS S3 bucket.test. So I should all this test. So it's S3 bucket.test, and then so it basically says no changes to the infrastructure, basically. So because it has already recognized that this bucket also exists and it's also in the state, and so it's not updating it. This is only required sometimes. I think only in certain scenarios where you have a long state, huge state file, and if you want to do something where it is really tedious to import all the Terraform state using Terraform import, this is another way of doing it. But be very careful, because some of these resources are very complex, and you can mess up the configuration in general. Also, make sure you have versioning enabled on your TF state. So for example, in my S3 bucket, I have already enabled versioning. So if you're updating, you have a history of the previous changes and you can revert back. But be very careful. As long as you do not apply the changes, it's fine. I think you do experiment and do the plans and check. But this is how you can use to, this is one of the mechanisms you can use to get out of a bad state or configurations that you have for some reason landed up into. So that's how you that's various aspects of how to sort of manipulate state, change state, use state, and read state or Terraform state. This is one of the concepts which are probably critical when you're using Terraform heavily. We'll switch gears into understanding how to work with Azure now. So in my, just like the AWS provider, you have the Azure RM provider, which is what you use for AWS resources. In this example, I'm going to just create a storage account, which is almost like not necessarily an S3 bucket, but it's an account which allows you to create containers similar to S3 buckets and also tables and many other different storage types. So in Azure, everything needs to exist inside a resource group. So I'll create a resource group and a storage account in my sample. So for example, if I show you my code here, I've got in the providers, I've got the Azure RM provider. I've just added this as an experimental feature, which I use for VARs. You can ignore that for now, but you don't really need this experiment. So I have the provider, and then I've got my resources that are to be created. So the resource group, a storage account with the appropriate configuration, and a container, which is basically like an S3 bucket, which is where, in this case, I would have used this to store the Terraform state. If I look at my Terraform state, it's blank, so I haven't really created this. If I show you my Azure account, I do not have any storage accounts in here. So this is the storage account I'll use. So the first step with when it comes to Azure is to make sure that you have first logged into Azure. So this isn't a detailed primer on Azure CLI, but the command I use typically is to use Azure login, and it will automatically open your browser. You log into your account, and that's it. And then it should show you that this is the subscription it has access to now. So in my case, that's what I was basically. That's what I'm logged into. If I show you my subscriptions, so that's the subscription I've got, and I have basically logged into that now. So once you're logged in, you just run Terraform. Just like Terraform init plan apply, it will automatically take the context of the subscription. So I've done Terraform init, just done Terraform plan now. Once I run the plan, it will show me the list of resources that it would create. So it basically says it's creating 3 resources. So it's creating a container called TF state, which is like a bucket. It's creating a storage account, which is this account. And then it's also creating a resource group, which is where the storage account is added to. So those 3 resources. So now if I do Terraform apply. So one difference between AWS and Azure, because of the way IAM works, is that with AWS, I was using AWS Wall every time, and that's because the configuration is in my config file, and it needs to use AWS Wall to log in. There is no easy way to just set the account just like Azure CLI does. It automatically exports the credentials and it stores them. The one thing I haven't covered here with Azure is if you have multiple subscriptions, you have to set the active subscription before you apply, add the code. It's a separate level of complexity. I'll just keep it simple for now because not everyone probably is well versed with Azure to that extent. So that's it. So it's created the resources. If I switch back to my subscription, sometimes the UI for Azure takes a bit of time to refresh. So although the resource has been created, it doesn't refresh immediately. There you go. So this is my storage account. So this is the what I set up from the code. And then as I said, I had this container, so TF state. So that's also been created as part of this Terraform apply. So again, very similar to same stages as the last one. I think there's not really a big change to what was executed. If I were to then run destroy and then do the same thing and destroy the storage account. So while that's happening, we'll just cover a few more concepts. So we went through the Azure provider. We've seen how that works. Now, if the next logical question is, okay, so it's great that you have a set of resources you can run. But what if I want to group some of these resources? So in my example, for instance, you saw I was creating a storage account and resource group. Now, if that storage account needs to have, there are many other features Azure provides, and similarly S3 and all of these resources that provide multiple features. So one of the features, for example, is encryption. So if you want to use customer managed keys, you have to use another capability called Key Vault, and then you need to provision other resources. So if you want a fully functioning storage account with this feature, you have to provision 10 or 15 other resources. So just like this one. So you have resource group, you have the storage account, you have to create a few policies for the accessing the key vault, and then you actually create the encryption key, and then you create a customer managed key. So when you have such a complex sort of set of resources, you need to provision to make an end-to-end, so create an end-to-end solution. The easiest thing to do is to create a module, and basically a module is just a container that combines multiple resources. So next time, if you want to set up a similar storage account, you just, rather than having to create all of these 6 resources, copy paste them again, you just use that module. So the way you do that is you basically have the same code as you did last time, so for the storage account, except that you put it in a separate folder on a separate repo, and then once you have that in a common place, you can just reference it using this module sort of instruction. So in this case, I have created a storage module folder. I put the code in there, and then I just leverage that as a module so that I can create as many instances of the storage account as I need to. And then I pass input variables, which is what you define in vars.tf. And then you can also use outputs from that using the module name and any outputs that are exported. So this is how you can sort of reuse infrastructure that's already been created. So for example, in my case, if I go back to, so this was the previous sample I showed you. What I've done is I've created this sample for modules. So I've got my same code, which I had previously in a separate folder. So I've got the storage account, the resource group, the provider I have excluded for now because you can put the provider in the main folder, the same variables that I was leveraging. And I have created this output variable, which is basically any parameters that you want to be used outside of this module later on, you define them as outputs. So I've created that folder where I put my Terraform code. And then from my actual resource, what all I'm doing is I'm saying just reference this storage account module. The source code is located here. And then you just pass the parameters. I can do this as many times. So basically I have the storage account 1, I can create a storage account 2, as long as I pass a different name to it or something like that, append a different value, I can create the same set of resources over and over again. So that's a benefit. And then I reference the same, the name of the storage account here when creating the second resource by using the outputs that I just showed you previously. Again, running the code is exactly the same, so there's really no difference. So you do Terraform init, which basically downloads all the modules and stores them locally in the Terraform portal. So you see the module here, and then Terraform LAN. So again, it's the same set of resources, 3 resources to add basically. And the one thing you will notice though is it has a different nomenclature for the resources. So instead of resource, they're all now prefixed with the module dot and the name of the module. So this is just a minor nuance, that difference that you should understand. When you are using modules, it slightly changes how the Terraform state will look basically. And that's it. And then I'm just trying to run apply on this code. So that's it. So I can show you how the Terraform state will look in that case as well. If I go back to my storage accounts here, obviously this storage account now doesn't exist because I had destroyed it previously. The new storage account is just about getting created. Take a few minutes here. Yeah, so there you go. It's created. The UI takes a bit of time. So while the UI is refreshing, let me just show you quickly. So if I look at the Terraform state in this case, there were 3 resources. So one is the container itself, which is managed .tsc. So this was the container. And then there is a module here. So you will see that anything that is provisioned using a module has this additional attribute in it. So it says module.storage account, and it's got a resource group. So all the 3 resources, so the storage account, the resource group, sorry, two resources would have the module attribute associated with them. And the third resource basically doesn't have that because it's just a resource basically. So that's how they differ in essentially a module versus a normal resource. But it's created the same storage account. And I think that's about it in terms of modules. So what we've covered today, obviously, is I've talked about AWS, how to manage credentials and run your Terraform code. We covered a lot of state management, how to use backends, how Terraform state can be stored on the cloud, and how it can be locked when you have multiple users using it. We talked about importing resources, manipulating the state and attributes and fields if you had any issues. And then finally, we talked about Azure credentials and execution and modules as well. That's all I had for today. I think I'll open it up for any questions.
Yeah, so there are a couple of questions. I think one question was, I believe everyone can hear me.
Yeah.
So this is from Harbux. So I'm opening the voice of Harbux. Just give me a moment. But the question, in fact, he has already typed in. What is the best practice for credential management in Terraform? Would you recommend using Vault or the cloud?
So I mean, when I don't know what cloud would mean. I think it depends. I guess the question is whether it's AWS. Sorry, if you're talking about Terraform Cloud, I think I mean that Terraform Cloud doesn't. It itself doesn't really provide anything, I guess. I'm not sure. But depending on the provider, you may have to use different mechanisms. Now, with AWS, typically, it depends on how you're going to run your Terraform. A lot of people run it on some server, whether it's a CI/CD pipeline, Azure DevOps, or a Jenkins server or whatever. And within there, you basically provide, depending, so with AWS, for example, you can use instance roles and things like that, which then assumes a role inside your particular account and automatically gets credentials and then runs it. At the end of the day, the principle, I think it's hard to summarize what is the list of options, but the best thing to make sure is you don't have to store credentials in a file statically where you are generating something and putting it, right? So just make sure as much as possible, use the native sort of assuming either assume roles or some service accounts with Azure AD and stuff to manage it. So you're basically not copying and pasting credentials. It's automatically done through in an automated manner using the native cloud sort of capabilities.
Any other question, guys? Before we start the question series, and this will be a fastest finger first kind of thing. I'm just sharing my screen. I'll pass on the first question to you, and you have to answer. I have already unmuted everybody, so anyone can unmute themselves and ask question directly to Mahesh now. And meanwhile, I'm sharing my screen for now. So just give me a moment. I believe you are able to see my screen. If people can confirm. Mahesh, are you able to see my screen?
Yeah, I can. Yeah.
Yes.
Okay. So yes. This will be just coming to that slide. So the first question is on your screen, which is like, which of the following is not a valid Terraform command? If you can just type in the right answer, or just try apply, init, import,
Update.
just type in. The first to type in is the winner. Yep, I will encourage everyone to type in. Okay, so we are moving to the next question. I think Harbucks is the first one, E. Then we have Asprit, and then everyone is E. So Mahesh, if you can confirm.
Yeah. So for the first one, it's E. Yeah. Update.
Okay. So Harbucks
Yeah.
is the winner, and thank you everyone for giving your answer. Next question: which of the following is false? A. Terraform core reads config and builds dependency graph. B. Terraform providers are plugins that implement CRUD functionality. C. Terraform state is generated during plan phase and shows all action to be performed as part of Terraform apply. Can you type in your answer? It started coming up. So again, so this time we have again people have started typing in. Again, this is Harbucks. So Harbucks is already won one. So we'll. So next is Biswajit Kadam, then Adi Lenar, and everyone is C. So Mahesh, if you can confirm the answer.
Yeah. So with the second one, it's basically C. Yeah. The Terraform state is not generated during the plan phase. It is updated upon apply. It's basically the Terraform plan that you can generate as part of the plan phase and can be stored if you need to. Yeah.
Okay, so Biswajit and Harbucks, welcome and congratulations. You have won the multi-cloud for you merchandise, the t-shirt, and we'll send you through the courier to you. If you can simply type in your email one-to-one or in the chat window so that we can cover that up and my team can take that email one-to-one, either me or to Gavaskar S. Please. So, and thank you Anand, Jobin, Fatima, everyone is correct. It's just like it was fastest finger pass. Next time we can add up more quiz like this, interesting quiz like this. And so Biswajit and Harbucks are the winner. So Harbucks and Biswajit. So okay. So Harbucks, if you can type in your email Okay, so there is okay. So the second question is from Asprit. If two people try to apply it same S2 bucket, how will Terraform counter the conflict?
You have to do locking, right? As I said. So if you don't do, if you don't have locks using DynamoDB, then there is no locks. It won't create any locks, and it will overwrite. So you may get into inconsistent state. So basically, I've done a Terraform plan, I apply, and in the meantime, if someone else had done a Terraform plan based on the previous state, and my resource wasn't there, then his state will get saved, and my state, my resource might get lost. So because it is always important to make sure if you're doing S3, add the DynamoDB additional capacity locking, which will ensure that you lock. It will lock the state before it does it. By default, there is no locking, which means it will overwrite, and the latest state will be saved.
So any other question, guys?
Makesh? Yeah, hi.
Yeah.
Can you hear me?
Yeah, we can hear you.
Yeah, the concern is like, is there any possible to create like any same S3 bucket as someone has put the point here? So like, let's assume I want to create a bucket like a Terraform core. So if someone is want to create a same name in different region or different account, so it will be considerable to accept by AWS.
No, S3 names are unique. As far as I know, you can't have the same name across regions. It has to be unique.
Okay, that's not possible, right?
No, that's AWS. That's an AWS constraint, actually. Yeah, so I don't think it's possible to have two.
Thanks for the answer. Yes, the second question is the module you are creating in Azure, right?
Mm-hmm.
So in case is this possible to remodify the modules, or else if something happened to the module, like in the while creating the input or output or resource, whatever is something, do we remodify the module is possible, or do we require to create a new module?
No. You can. You can obviously. I mean, that's the benefit, right? So the more idea behind modules is the example I had, storage account. You can do it with storage account, S3, whatever, right? You have a module. Hello, let's say. I'm Mahesh. If new features, capabilities come out from the cloud provider, and you want to supplement, augment that module, add more capacity, capabilities, some features that are available, you can always add new sources, update resources. You just have to be, and then you apply the change, and it will automatically take those changes and apply. It just works like any other resource, honestly. The only thing you need to be careful of is some capabilities require recreation of the resource. So just make sure you look through the documentation, and I think Terraform's got an amazing sort of documentation for providers. Just make sure you look at the resource, what properties you're trying to add, and if the properties will recreate your resource. So sometimes certain things, so for example, S3 name, bucket name, if you change the name of the bucket or the schema or nomenclature, then it will recreate the bucket, which is dangerous, right? You may lose the data. So just be mindful of the type of changes you're making. But if it's just things like encryption, for example, that I was showing you, that doesn't recreate anything. It will just append as a new feature extend. So just be careful. But yeah, that's the idea. You should be able to extend it or change the modules, update over time. And if you're doing that, make sure you also version them. And there is a way to reference a particular version of a module, so you can slowly adopt those module versions as you need them. Okay.
Thanks, Magesh. Thanks for the answer. Very helpful.
There was one
question, guys. Before we.
There's one question from someone on Azure resource groups, I think. So I think somehow maybe there's been some confusion. My experience, I think the question says that if you have multiple resources in a resource group, and you can't import that resource group because it has other resources, it would try to delete or something. I didn't understand fully the issue, but in my experience, if a resource group has multiple resources, you can still import the resource group. It doesn't impact the resources. It shouldn't impact, because they are both, Terraform treats each resource separately. So even the resource group itself is a resource. So I don't see any problems with that, but go ahead.
That's correct, Mahesh. The point I was trying to ask is, so let's say there are multiple resources which were created outside of Terraform inside the resource group, and you just import the resource group and try and deploy some other infra. Now, when you do a Terraform destroy, it will try and delete the resource group, right? Because Terraform now manages that, and that can cause issues. So how do you work around?
Yeah,
that
so,
issue.
so best to keep, so this is where you're thinking how you organize your resource group is really critical, right? So make sure that if you have that, scenario, then I would say, first off, you shouldn't have two big resource groups. Make sure your resource groups are as small and as possible, self-contained, so they contain only certain kind of resources. Don't have one resource group that has hundreds of resources, for example. I think that's too big. But then in general, make sure your Terraform stack resource groups are not sort of distributed. So if you have a stack, for example, and we'll talk about this in the next session, try not to put two different stacks in one resource group, for example, right? And I'll talk about stacks in the future again. So basically, the idea is keep them. So organize your resource groups in such a way that your Terraform doesn't split out, resources from one resource group in one set code and the other in the other. So you need to make sure you're organizing your Terraform code appropriately and keep the stack and the resource groups sort of one-on-one, at least one-to-one mapping. That way you don't have this problem. The other thing I have tried in the past is locks with Azure, but honestly, I've never been able to get it to work properly. There's always been a challenge. I think it doesn't work cleanly with Azure. So, but it is possible that the way to work around that is you manage it in Terraform, but then in your situation, right, the resource group, and then lock it manually, because I think I've always seen issues with running Terraform against a locked resource. And then if you want to do something, unlock it and make that change. But it's still a bit risky, I would say. Just work on making sure you organize your resources properly.
Understood. Thank you.
Cool. Any more? Good.
Any other question, guys? Can you hear me now? Mahesh, can you hear me?
Yeah, I can hear you. Can you hear us?
Yes.
Yeah,
So
okay.
any other questions? You're most welcome. Else we'll wrap up and we'll give you the certificate link. So for obviously there will be Alibaba Cloud certificate at the end of the session. I have already passed in the series. Once you go into the series, you will be able to either you go on the session which is running now, or in the past session, if you have to go through it, you can directly click in this link, this toggle, and you'll see all the sessions that are there. And you can also come up here in the series link that I've given, and you'll see watch now, which is for the event that has happened. This also will show up watch now, and this is for the next slot or next event that is scheduled on 27 November. You can also download the calendar from here. Simply add this calendar to your Outlook, or you can directly go there in this event page and you can do it. To claim a certificate for this one, participant certificate, there's one more goodies with us, which is like once you take your certificate, and this is just to respect the speaker, right? So we request everyone to share it on LinkedIn so that we can pass on the voice to more and more technologies across the globe. And it's only possible, it's not just by us, but when you share your certificate in respect to the speaker today on LinkedIn and other platform which is there. But try to use the button here so that we are able to pass you on the goodies, and we're able to connect with you through our Telegram channel. So whenever you share, you try to join our Telegram channel, which is there by you can go through this connect link, right? Help center or connect link. Multiple links are there. You can search for Telegram, telegrams.com/multicloud for you will find out, or you can pass on our message through one of the even through this Facebook Messenger chat, and we'll be able to understand that you have shared it. And obviously our system automatically catches it up when you take the certificate, and automatically if more and more people have viewed your certificate, you are eligible for the goodies. So you go on the page. Once you are on the event page for this session, not on the series page, you will see there will be a certificate claim post login. It's just you have to log in here with name, email, and phone number, nothing more than that, and then you will be able to claim your certificate from it. The certificate code for today's session is, I will just pass in, is Z7SS2K. So you can use this to claim your certificate. Okay, so it's Z7SS2K. Gavaskar, if you can type in out Z7SS2K. Okay, and then you can link to if you have any issues claiming your certificate. Now the team has also started posting certificate directly. If the people have already completed the session today. So even if you don't get your certificate, we'll try to send your certificate directly through our automated system. So thank you, Mahesh, for your nice masterclass today. We have another one on in the November, which is like best practice and uses enterprise environment, and which is on Saturday 27 November. Anyone can download the calendar from here also. So thank you everyone for joining today, and thank you once again, Mahesh.
Thank you.
Yeah. Thank you everybody. See you in the next session when the Alibaba Cloud certification exam will happen, and you can claim your certificate directly from Alibaba Cloud. Thank you once again, and have a nice weekend.
You too. Thank you. Bye.